Hi guys, today we're going to look at a second type of transformation, moving on from translations to something called line reflections. A line reflection is really when you're taking a shape and you are flipping. It's a flip. You're flipping over a line. That's why it's called a line reflection. So what you're going to end up seeing is that the figure is going to look somewhat backwards or upside down from the position that it originally was in. If you look at the first image I provided for you, just as an example, they started out with triangle ABC on the right-hand side, and they reflected it over the y-axis. That was the line that they reflected over onto the other side to create A prime, B prime, C prime. So what you'll notice is that every point, if I look at point A, for example, every point is the same distance away from the line of reflection. So if you count, A is 2 units away from the y-axis, and A prime is 2 units away from the y-axis. B is 1, 2, 3, 4 units away from the y-axis. B prime on the other side is also 1, 2, 3, 4 away. So it's the same distance or equidistant, same distance from the line of reflection. That's how you create a reflection. And that's one of the properties that you'll notice, that it's the same distance away from the x-axis, or from the axis, in this case the y-axis, from whichever line you reflected over. Okay, if you look at the second example down below, we have another line reflection. This time ABC started up here, and it was reflected over down to the bottom. So it was reflected over this line, which is the x-axis. This is a reflection over the x-axis. And I didn't write it up here. This is a reflection over the y-axis. So you're always reflecting over a particular line. And again, you'll notice that the same distance away, like A is 1 unit away from the x-axis, A prime is also 1 unit away, but on the other side. C is 2 units away from the x-axis, C prime is 2 units away, but on the other side. So we're going to do some examples like this, and all you're doing is literally just counting this number of units away from that line of reflection. So if you look at example 1, it asks you to reflect across the x-axis. So I'm going to just count from A to the x-axis. X-axis is here. Let me do it in red. That's the x-axis. So I'm going to count. A is 1 unit away. So if A was 1 unit away, then I go 1 to the other side and I label it A prime. R was 1 unit away, I label that R prime, 1 unit on the other side. Z, if you count, is 1, 2, 3 units away. So you stay along the same line and you go 1, 2, 3 the other way. There's Z prime. N was 1, 2, 3, 4, 5 units away from the x-axis. I'm going to count 5 to the other side. 1, 2, 3, 4, 5. Staying along that same line. There's N prime, and then I just connect, and there's my figure. Use a ruler when you're doing this. Okay, and it looks upside down. So maybe try the next one on your own. You can pause me and try it on your own. Again, we're reflecting across the x-axis. So I'm going to count from A, 1, 2, 3. So I go 1, 2, 3 on the other side. There's A prime. D is 1, 2, 3, 4, 5. I go 1, 2, 3, 4, 5 on the other side of the x-axis. That's D prime. M is also 5 units away here. So there's M prime. W is 1, 2, 3, 4 units away. 1, 2, 3, 4 on the other side. There's W prime. And you just connect W to A to D to M prime. And now the figure looks upside down. So we're going to move on now to reflection in the y-axis. So reflection in the y-axis, you're just basically counting the number of units to the y-axis. Now in this first example, or example 3 rather, you have A, I'm counting to the y-axis. That's the line I'm reflecting over. So I'm going to just highlight it so you guys can see it. I'm reflecting over this line. So A is 2 spaces away from the y-axis. I'm going to count 2 spaces to the other side. There's my A prime. F is 1, 2, 3, 4, 5 away. I go 1, 2, 3, 4, 5 to the other side. That's F prime. P is also 5 to the other side. That's P prime. And W is on the y-axis. So if ever you have a point that's on the line that you're reflecting over, it's going to reflect onto itself. W prime is right on top of W. And it's just going to connect W, A, F, P, and then back to W. And use a ruler when you're doing this. I can't use a ruler on this program. Okay, so maybe try to pause me and try example 4 on your own. Again, we're reflecting over the y-axis. This is your line of reflection, and you're going to count. W is 2 spaces away, so you go 2 spaces to the other side, W prime. S is 2 spaces away. I go 2 spaces to the other side, S prime. P is 1, 2, 3, 4 away. I go 1, 2, 3, 4 to the other side, is P prime. I is 1, 2, 3, 4, 5 away. I go 1, 2, 3, 4, 5. There's I prime. And now it's going to look backwards. The figure looks backwards because it was reflected. So in terms of like the original and the image are still congruent. They are exactly the same shape and size. They are congruent, but the orientation changes. The orientation has changed. It's now facing in a different direction. It's not facing in the same direction as it was originally. And that's one way you can easily recognize a reflection or a line reflection, is that its orientation has changed. Okay? Now we're going to reflect over some other lines other than the X and Y axis. Oh, actually, you know what? Before we do that, we have one more example across the Y axis. In this example, I purposely am doing this one. You're reflecting this rectangle across the Y axis. But what's going to happen is you're going to have an overlap. So this is an example of how you deal with overlap. When you have an overlap, you just count, your reflection line is the y-axis. So F is going to move to the other side 1 unit away from the x-axis. It's going to go here. G is 1, 2, 3, 4 away from the y-axis. So you go 4 to the other side. 1, 2, 3, 4. There's G prime. D is on the left side, so it's going to flip to the right side, D prime. And B is on the right side, it's going to flip to the left side here, 4 units away, B prime. So your image could overlap with the original. That's totally possible. Okay? Now, I'm going to take a look at reflections over lines that are not the X and Y axis. Okay? So we're going to take a minute to look at... So I'm looking at lines, reflections over lines that are not the X and Y axis now. If you remember back to our linear functions unit, we learned special lines. So we have to kind of review really quickly. Special lines, all vertical lines are X equals a number. Their equation is X equals a number. So for example, you might have the line X equals 5. That means that on the X and Y axes, you go to 5, 1, 2, 3, 4, 5, and a vertical line on 5 like that has the equation X equals 5. That was one type of special line. The other type of special line was horizontal lines. Horizontal lines always have the equation of Y equals a number. For example, like Y equals 3. The line Y equals 3 is if you draw X and Y axes and you go to the Y3, meaning up 3, 1, 2, 3, a line going horizontally through 3 is the line Y equals 3. We're going to be reflecting across these lines. So if you look at example 6, reflection across X equals 1. So you draw in the line X equals 1 is a vertical line. You draw it in, and you're going to reflect over that line. So if you look at G, G is 1 unit away from that vertical line that we just drew, X equals 1, and you go 1 to the other side. So G prime is 1 space away on the other side. P is 1, 2, 3, 4 away from X equals 1, so I go 1, 2, 3, 4 to the other side. There's P prime. So you're not counting to the x-axis or y-axis, you're counting to this line that you drew in. C is 1, 2, 3, 4 away, so 1, 2, 3, 4 away, C prime. And now I'm going to connect, and now it looks backwards. And it's all based on this line X equals 1, this vertical line. Okay, so if you look at the next one, we're reflecting across the line y equals -2.